All right, section 2 deals with verifying trig identities. Has some similar things from section 1, except for all of these questions, you will know what you have to get for an answer before you even start. Now, some guidelines that you should follow to verify identities. First thing is to work with one side of the equation, usually the more complicated side, because it's easier to take a complicated thing and make it into a simpler thing than it is to take a simple thing and make it into a complicated one. Now, if both sides look complicated to you, then just pick a side. Once you've picked your side, then you have to start trying to figure out how to get that side to look like the other one. So you want to look to factor expressions, add fractions together or subtract. See if you can square something, square a binomial, which is something that's two terms, or create a monomial denominator. That means just a single denominator. Those things will help you in trying to verify an identity. Then look to your fundamental identities, that colored sheet that you have. Note what is on the other side of the equation. That's always good to know. What are you trying to get to? And pair sines and cosines, secants and tangents, and cosecants and cotangents. Those things work together well so that you can do things with them to try to get one side to look like the other. If none of those things work, then take everything in the problem and try to convert it all to sines and cosines, and then go from there. And finally, do not just sit and stare at the problem. Try something. Even paths that lead to nowhere give you insights. There might be some problem where you'll try something and you'll be working through it, and then it's not going to turn out to be the correct thing. Don't erase it. Just leave it there and rewrite the problem and start over, because then you can look back and use those steps that you did before as reference to see if you're going in the same direction or not. Sometimes you might have to try things once or twice, maybe even 3 times. Other times you might get it on your first try. But if you just sit there and stare at the problem and say, I don't get it, you're not going to get anywhere. You just got to start trying things that you know. These things here. All right, so let's look at some examples from your assignment. So here's the first one, is problem number 5. It says cosine squared of beta minus sine squared of beta is equal to 1 minus 2 sine squared of beta. All right, for this one, so, you're supposed to pick a side, the one that looks more complicated. Well, they're both kind of about the same, so you have to pick one of them. And we're going to look at the left side. And on the left side, you have cosine squared minus sine squared. Well, there is no fundamental identity for that, but we do know that sine squared plus cosine squared equals 1. And we're trying to get to where we only have sine on that side. So we want to get rid of this cosine squared thing, so we can get it to all sines. Well, if you take this identity and move the sine to the other side, you would get cosine squared is equal to 1 minus sine squared. So that means that this can turn into 1 minus sine squared of beta. And then we still have minus sine squared of beta. And now, hey, we can simplify this, because those two things are negative sine squared of beta, and that's 2 of them. So then we have 1 minus 2 sine squared beta. And this is that, and we verified the identity. Now, had you picked the right-hand side, you could have done that as well and said, okay, I'm going to pick this side. Well, what do we know about 1? Hey, it is sine squared of beta plus cosine squared beta minus 2 sine squared beta. And then you can combine the sine and the -2 sine. So that gets you cosine squared beta minus, let's see, 1 minus 2 would be 1 sine squared beta. And now this is the same as that. So there's two ways you could do that problem if you pick the left side or the right side. Now that's not the only two ways that could be done. There's many different things you could do to get to this, to show that this is an identity. Those are the two that we're looking at. All right, here for number 10, it says tangent squared of y times cosecant squared of y minus 1 has to equal 1. So let's see. If we distribute that times that, because we're going to pick the left side because that has more stuff on it, you would have tangent squared of y times cosecant squared of y minus tangent squared of y. And let's see, tangent is the same as sine squared over cosine squared times cosecant is 1 over sine squared minus tangent squared of y. And then by your multiplication properties with fractions, the sine squareds go away and you have 1 over cosine squared. And 1 over cosine squared is secant squared of y minus tangent squared of y. And secant squared minus tangent squared is an identity, which is 1. And then you're done. Now the other way you could look at this is same thing, but just before, when you're starting this right here, cosine squared y minus 1, that's one of those Pythagorean identities. It equals cotangent squared of y. And then you have cotangent times tangent squared of y. And tangent is like 1 over cotangent squared of y times cotangent squared of y, and then those divide out and you're left with 1. Or you could even say, oh, tangent is the same as sine over cosine, and cotangent is cosine over sine, and those are all squared. And then sine squares divide out and cosine squares divide out, and you're left with 1. So you have options in doing that one. All right, this next one is secant of pi over 2 minus x over tangent of pi over 2 minus x equals secant of x. Well, from your properties, secant of pi over 2 minus x is equal to cosecant of x. And tangent of pi over 2 minus x is equal to cotangent of x. And then cosecant is the same as 1 over sine. Cotangent is the same as cosine over sine. And then by your properties of fractions, multiply by the reciprocal. The sines divide out and you're left with 1 over cosine of x, which turns into secant of x. And that is that. All right, our next example, number 29. We have sine of x cosine of x plus cosine of x sine of y. Oh, sine of x cosine y plus cosine x sine of y. And then cosine of x cosine y minus sine of x sine of y. And that equals tangent x plus tangent y, 1 minus tan x tan y. All right, so let's see. The left side looks to be a little more complicated. Now, in looking at this side, if you look at here's a plus sign and here's a minus sign and here's a plus sign and here's a minus sign. So this kind of matches up with that, and that kind of matches up with that, and this kind of matches up with this, and this matches up with that. So basically they're the same thing as far as where things are at. And here we have a 1. Well, how do you turn this into 1? You would have to divide by cosine of x, cosine of y, which you can do as long as you do that to every single part of this left side. So if we take each one of these things and divide them by cosine of x, cosine of y, we would have sine of x, cosine of y, divided by cosine of x, cosine of y, plus cosine of x, sine of y, divided by cosine of x, cosine of y. And then we have cosine of x, cosine of y, divided by cosine of x, cosine of y, minus sine of x, sine of y, divided by cosine of x, cosine of y. Because as long as you do something to everything on that side, it's okay. So then let's see. In this one, the cosine of y's divide out, and we're left with sine of x over cosine of x. Plus, in this one, cosines of x divide out, and you're left with sine of y over cosine of y. Over, and now here, the cosine is of x, and the cosine of y turns into 1. And here we don't divide anything out, so that stays as sine of x, cosine of x, sine of y, cosine of y. And what do we know about sine over cosine? Hey, that is tangent of x. Sine over cosine, that would be plus tangent of y. Over 1 minus sine over cosine is tangent of x. And sine over cosine is tangent of y. Look at that. We're done. All right, moving on to 34. Square root of 1 minus cosine x, 1 plus cosine x equals 1 minus cosine of x over sine of x. Okay, I'm saying x, theta, same thing. Well, here we have a square root, and remember with square roots, you can't have a fraction underneath, so you should write that first over that. Now, in order to get rid of a square root when you have something like try 1 minus cosine theta, you have to multiply by the conjugate thing. So 1 minus cosine theta. So now when we multiply the numerators, square root, oh hey, these are the same thing. So that can be the square root of, and then 1 minus cosine theta squared. Now on the bottom, they're not the same thing, so then when I multiply that, 1 times 1 is 1, minus cosine plus cosine is nothing, and then cosine times it would be 1 minus cosine squared theta. And then from our Pythagorean identities, the denominator is going to be the square root of sine squared of theta, because 1 minus cosine squared of theta is equal to sine squared of theta. And the numerator could stay like this for now. And then, when you have a square root and a squared, those things go away. because they are inverses of each other. So you have 1 minus cosine theta. And then same thing here, square and a square root, because this is the same as sine. That's that, but we don't write it this way because that way you don't have to put the parenthesis in all the time. You can just write it as sine squared theta, but that's what it means. You take sine of the angle and then square it. And the squared and the square root go away, so you're left with sine of theta. And now we have to have this be absolute value here, because when you take the square root, you can't take the square root of a negative number, otherwise you get something with an I, and we're not dealing with imaginary things. So that's why this denominator has to be a positive value. So that's why the absolute value symbols are there. Hey, and we've verified our identity. Next one here, secant to the fourth minus tangent to the fourth equals 1 plus tangent squared. Let's mess with the left side. And since this is to the fourth and that's to the fourth and a subtraction, we can write secant squared of theta minus tangent squared of theta times secant squared of theta plus tangent squared of theta. And then from our Pythagorean identities, that turns into 1. And so then we have, no, not that one. Sorry, got that backwards. Secant squared minus tangent squared is 1. So then we have secant plus tangent squared. And we're trying to get to all tangents. So what do we know about secant squared? It is 1 plus tangent squared theta plus tangent squared theta. And then tangent squared plus tangent squared is 1 plus 2 tangent squared theta. Okay, and we verified this identity, because that is that. Finally, we have natural log of cotangent of theta equals natural log of cosine minus natural log of sine. Okay, this is similar to that problem from the last assignment where you had logarithms, except you weren't given two sides. But we're going to mess with this side because that has more in it. And with the subtraction sign here in the logarithm, this turns into ln of the absolute value of cosine theta. We can put that like that over sine theta, because subtraction means division. And then cosine over sine is the same as cotangent theta. And we have ln of cotangent theta. And this is what we were shooting for. Hey, we're done. So those are some examples of verifying identities. And like I said, you'll get plenty of these problems to deal with in this section. The more of them you do, the better off you're going to be, because then you become more familiar with all of the things that you can do. And don't forget, try something with every single problem. Try to work through it a little bit, write down some things that you know, and just go from there, and eventually you'll figure them out.